All right, how does that help statistics? What the heck have we done? Quick recap here. Remember from at the end of the last lecture where we finished talking about probability distributions and densities, we now have this view where we have it's kind of interchangeable whether you're talking about a distribution or density or code or a population data set. All of those are just some way it's the source. It's like the ground truth, the reality, and then we have our data. And our data is some small subset of that population, or it's a sample from the distribution, or it's the numbers that come out when we run this code one time. And all that stuff on the left, it's all representing the same underlying data generating process. And what we did today is that we learned that we can say something. Those data generating processes can be represented by different DAGs, or there are different relationships between the variables that we can talk about in terms of independence or conditional independence. And it turns out that what we can say about that data generating process, which in reality we don't get to see. We just get to see this data that we go and measure for some small subset of people. And it turns out that what we can actually say with the data that we have, it depends on those conditional independencies or what kind of DAG we can use to represent that distribution. And so we will see that later in the course how that comes up. But independence is, you cannot understand the kinds of statistical assumptions that you're making without understanding what they imply in the real world, right? Whether your method is going to give you an answer that's right or wrong, you can't understand whether that's the case without understanding what independence is in the first place. So that's why we've spent so much time on that and had a whole week's worth of lecture on it. Hopefully that's great. And we'll see you in the next week.